we're going to practice doing a couple of electron configurations. So we'll start with some metals. And we'll start kind of simple. So we'll just take a look at lithium, for instance. If we look at the periodic table, we see that lithium is right there. And lithium has atomic number 3, so it has 3 protons. Neutral element would have 3 electrons. So where are we going to put those 3 electrons? Well, if we follow our 3 basic principles, which we'll review right now. First being the Aufbau principle, it says that the electrons are going to go into the lowest energy level first. Next is the Pauli exclusion principle, which says that if you put 2 electrons into the same orbital, one would have an upward spin, the other one would have a downward spin. And the third is Hund's rule, which says that if you have the option of spreading electrons out in an energy level or a sublevel, that the electrons are going to do that before they double up. So the placement of our 3 electrons for lithium, start at the lowest energy level, the 1s. We put 2 electrons into that 1s orbital. We have 1 electron left over. It goes into the 2s. So the electron configuration for lithium would be expressed as 1s2, 2s1. Now the outermost electrons are going to be the most significant for us. So that's going to be the 1 2s electron there. So we said lithium has 1 valence electron, 1 electron in its outer shell. Next, let's take a look at something a little bit bigger. We'll look at magnesium. So if we look at the periodic table, magnesium is element number 12. So the neutral atom would have 12 electrons. So we're going to go ahead and fill that in. Obviously, we can start with the 3 that we already have here for lithium and just add on to it. So there's 3, 4, 5, 6. Again, using Hund's rule, we're going to spread out. 7, 8, 9, 10. 2 more electrons. 1, 2. Going up to the 3rd level, the 3s orbital. So we would write down the electron configuration for magnesium as 1s2, 2s2, 3p, forgot about my 2 s's, or 2 p's, 2p6, and 3s2. So here, the outermost shell, the highest principal quantum number, is that 3rd shell. So here we would say magnesium then has 2 valence electrons. What this does, it allows us to then evaluate the bonding that these elements might have. So I notice that both of these have relatively few valence electrons. In terms of bonding, what elements are going to try to do is fill up their outer shell with electrons. So both of these being metals and having few valence electrons, they're both going to tend to lose electrons. This is why metals tend to form positive ions. They lose electrons and have more protons than they have electrons, and so they have a positive charge. Now, if we take a look at nonmetals, and we'll start with oxygen. So oxygen, let's take a look at where it is on the periodic table. Oxygen is located right up here, right? So it's element number 8, which means it has 8 protons. Neutral oxygen atom would also have 8 electrons. We're going to go ahead and fill those electrons in. So we have 1, 2, Pauli exclusion principle, spin up, spin down, 3, 4, 5, 6, 7, 8. So again, the electrons spread it out before we doubled up. And so the electron configuration then can be expressed as 1s2, 2s2, 2p4. And all I did is count up the number of electrons in each sublevel and put those in there. The highest principal energy level is the second level. So that would include the 2s as well as the 2p. So looking over here, these are my valence electrons, my outermost electrons. So I would say that there are 6 valence electrons for an oxygen atom. So let's try chlorine. So chlorine, we take a look at chlorine on the periodic table, and it's atomic number 17, which means it has 17 protons. So a neutral atom would have 17 electrons as well. We're going to go ahead and fill those in. So we can start with the 8 that are already present for oxygen. Let's get rid of the red dashes there. So it's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So there are all 17 electrons for chlorine. The shorthand configuration for this then, 1s2, 2s2, 2p6, 3s2, 3p5. So that would be the configuration for the chlorine. And again, looking at the outermost electrons, 3 is the highest principal energy level, so we would count both the 3s and the 3p's. So those all count as valence electrons. So we have 7 valence electrons for chlorine. So you can see that nonmetals tend to have more valence electrons. So in order to kind of fill up their outer shell of electrons, they're going to tend to gain electrons, which means they would have more negative charge than they have positive charge, and they would form then a negative ion, which we refer to as an anion.